Hello students, today we are going to learn a very important chapter of mechanics, that is Newton's law of motion. In this chapter we will cover the points. First we will understand about the three laws of motion, first law, second law and third law. In that laws we will understand about the linear momentum, conservation of linear momentum, impulse. These are the new physical quantities for us. Then we will learn about various new forces, that are tension force, spring force, etc. Then based on the various forces, we will learn about the connected motion, the three types of connected motion. Then we will learn about the pulley problems, the braking stress problems, then the further advanced version of pulley problems, that is constrained motion. The next we will understand about the motion along the inclined plane, the very important force, frictional force, and problems based on frictional force. Then non-inertial frame of reference, that is frame of reference in which Newton's laws are not applicable. Based on the non-inertial frame of reference, we will learn about some circular motions. In that we will understand the conical pendulum and motion of a vehicle on a banked road and a leveled circular road. And we will end this chapter with some of the previous year examples. So let us begin. Before learning about the Newton's laws of motion, first we have to understand what is force. Simply, a force is a push or pull or a shear, or it is combination of all of three. This is a pure push force, this is pure pull force, and the force acting along the surface is called shear. Now let us begin with the first law of motion. The Newton's first law of motion is also called law of inertia. The first law states that the body will not change its state of rest or state of uniform motion until and unless some unbalanced external force is applied on it. That means if object is at rest, then it will continue to be at rest, and if object is in uniform motion, remember uniform motion, that means constant velocity, so its speed and direction both are constant. If object is in uniform motion, then it will continue to be in uniform motion until and unless some unbalanced, without any unbalanced force, there is no change in motion. So until and unless some unbalanced external force is applied on it. Here the external force means the force acting on the system and not within the system. For example, if we take a car, we cannot move a car by pushing it from inside. To move the car, we have to push it from outside. So to move any object, to change its state of rest or state of uniform motion, the force should be unbalanced and it should act externally. This law defines the force, because from this law, first law, we can find that what is force, what are the effects of force. So the Newton's first law defines both inertia and force. This is frequently asked in exam, that which law of Newton defines force. Most of the student gets confused between first law and second law, but the answer is first law. First law of Newton will define the force. The second term it defines is inertia. So what is inertia? Inertia is the inability of any object to change its state of rest or state of uniform motion on its own. The object cannot automatically start moving. For example, this is object of mass 5 kg. This object is resting on some surface. Until and unless we have applied some external unbalanced force, this object will not move. So, for any object to start its motion or change the uniform motion, we need some external unbalanced force. This property of any object to resist the change of state of motion, to resist the change of state of motion is called inertia. There are basically 3 types of inertia. First is inertia of rest. It is the inability of an object to change its state of rest on its own. So that it means that object cannot start its motion on its own. For example, if you are sitting in a car, initially the car is at rest. Now, when we suddenly start the car, you tend to lean in backward direction. Why? Because when you are in car, due to inertia, you tend to be at the same position you are resting. Now, when the car starts moving in forward direction, you want to stay in that position only, but the lower part of you, which is in contact with car, will move in forward direction, and the upper part, which is not in the contact with car, will tend to stay in same position. So with respect to car, you will lean in backward direction. So leaning of us in backward direction is due to inertia of rest. Second type is inertia of motion. Inertia of motion is the inability of an object to change its speed on its own. For example, we are sitting in a car that is moving with constant speed 40 km per hour. So our tendency is to move constantly with car with speed of 40 km per hour. Now, when the speed of car is decreased, let's say now it has become 20 km per hour. But our body has the tendency to move with constant velocity 40 km per hour. So again, car will move in backward direction with respect to us. So we will lean in forward direction when the speed is decreased. The third type is inertia of direction. The inertia of direction is the inability of an object to change its direction of motion on its own. For example, we are taking example of same car. When we are sitting in a car and the car takes sharp turn, let's say in leftward direction, then we tend to lean in the opposite direction of turn, because initially the car was moving on a straight path. So our tendency was to move on a straight path. Now suddenly the car takes turn in this direction, but we want to keep moving in straight direction. So we'll get thrown in the opposite direction of the turn. This is due to inertia of direction. So there are 3 types of inertia. Inertia is basically the tendency of an object to resist the change in its state of motion or state of rest. Now, what are the factors on which inertia depends? Mass is the measure of inertia. Remember, inertia is not a physical quantity. Inertia is property. It is property and not a physical quantity. Inertia is a physical quantity that is measured with help of mass. If mass of an object is more, then it is having more inertia. We know that moving any heavy object is more difficult compared to moving the lighter object. So more the mass, more is the inertia. Now, before moving on to second law of motion, let us understand about a new physical quantity that is called linear momentum. The linear momentum is defined as the amount of motion contained in a body. Momentum is denoted by small p. Momentum is the product of mass and velocity. So P is equals to m into v. Here momentum is a vector quantity and SI unit will be, SI unit of mass is kg and SI unit of velocity is meter per second. So SI unit of momentum will be kg meter per second. Now let us see one example on change in linear momentum. It is given that a ball moving with a speed v hits vertical wall with an angle theta with horizontal and rebounds with same speed and at same angle as shown in figure. We want to find the change in linear momentum of the ball. Let's say there is one ball. It is coming in this direction with speed v. After hitting the wall, it is rebounding with same speed v. Remember, it is moving with same speed and not with the same velocity, because after rebounds the direction of motion will change, so velocity will change. We want to find the change in linear momentum of ball. Change in any quantity is given by final minus initial quantity. This is making an angle theta with horizontal. So let us divide this quantity in horizontal and vertical components. So it is making an angle theta with horizontal direction. So horizontal component will be v cos theta, but it is along the negative x-axis, so it will be minus. The vertical component will be in downward direction, that is equals to v sine theta. Let us divide the initial velocity. The horizontal component will be, if this angle is theta, this angle will also be theta. So it will be v cos theta along the positive x direction, and the vertical component will be v sine theta along the negative y direction. If we see the initial and final velocity, then the vertical component is not changing, not in magnitude and not even in direction. The vertical component is not changing. The component that is changing after rebounding is the horizontal component of velocity. So when we subtract the momentum, this vertical components will get cancelled out. So if we write P final will be equal to m into v final minus m into v initial. Let us take m common. Here v final will be this vertical component will get cancelled out, so we will write only the horizontal component. Final velocities along negative direction, so it will be minus v cos theta, minus initial component of velocity along horizontal direction is plus v cos theta. So this will give us the answer minus 2mv cos theta. If we take the magnitude of change in linear momentum, that will be equal to 2mv cos theta. Here keep this in mind that the component of momentum or the component of velocity parallel to the surface does not change. Your wall is vertical, so the vertical component of momentum is not changing, but the normal component to the surface will change. So note, the component of linear momentum parallel to the surface will not change. Only normal component, that is perpendicular component, will change. After understanding the linear momentum and change in linear momentum, let us understand the Newton's second law of motion. It states that the rate of change of linear momentum is directly proportional to unbalanced external force applied. Again, it is talking about unbalanced and external force. If we write the statement mathematically, it is given that rate of change of momentum. Whenever rate is given, we will divide the quantity with time. So divide change in momentum with time, but we are talking about small changes. So F is directly proportional to dP by dt. But dP can be written as mdv because mass can remain constant. So F is directly proportional to m dv by dt. Here we have taken mass constant because on application of force, the mass of the object is not changing, but its velocity is changing. So we are taking mass constant and velocity variable, but this is not the necessary case. But dv by dt is equals to acceleration. Rate of change of velocity is acceleration. So F is directly proportional to ma. Here, if we change proportionality into equality, then F is equals to kma. But if we choose the units, in SI unit, mass is 1 kg, acceleration is 1 meter per second square, and force is 1 Newton, then the value of K will be 1. So F is equals to ma. This is the mathematical formulation of Newton's second law. So Newton's second law gives the formula of force. The first law defines force and second law will give us the formula of force. Now, as I have said, it is not necessary that always velocity changes and mass remains constant. So there will be two cases. In first case, when mass is constant, we can write F is equals to m dv by dt. But there are some cases in which velocity is constant and mass is variable or mass is changing. In this case, force is equal to v dm by dt. The case of variable mass is rocket propulsion. The example of rocket propulsion we'll see after the Newton's third law of motion. So keep this in mind that it is not necessary that mass is always constant. Now let us see different units of force. The SI unit of force is Newton. We know that F force is equals to MA. So 1 Newton is equals to 1 kg into 1 meter per second square. So 1 Newton will be equal to 1 kg meter per second square. The CGS unit is dyne, that is equals to 1 gram per centimeter second square. The conversion between Newton and dyne is 1 Newton is equals to 10 power 5 dyne. There is also another unit called gravitational unit. This is the unit used to write weight. The gravitational unit is 1 kg force or 1 kg weight. It is the amount of gravitational force acting on 1 kg object. So force will be equal to mass into acceleration. Here acceleration will be due to gravitational force. So m into g. We are taking mass as 1 kg. So F will be equal to g Newton. So 1 kg force or 1 kg weight is equals to g Newton. The value of g is 9.8 or sometimes it is taken 10 Newton. Converting it in CGS unit, taking gram instead of kg, then 1 gram force is equals to 1 gram weight, both are same thing, that is equal to 980 dyne. Now let us see one example on force. An object is moving on a circular path with constant speed. Remember here speed is constant, not velocity. It is moving with constant speed 20 meter per second. The mass of object is 1 kg. We want to find the force on object while moving from A to B. Here we have to understand that in this case mass is constant, velocity is variable, because velocity includes both the things, magnitude as well as direction. In this particular case, the magnitude is not changing, but direction is changing. The force is defined as mass into acceleration, and acceleration is defined as final velocity minus initial velocity upon time. Initially it was at point A, after some time it is at point B. Let's say it is at point B after t is equals to 2 seconds. We want to find the acceleration, then we can find the force. Acceleration is v minus u upon t. The final velocity at point B is along negative x direction. So v is equal to minus 20 I cap meter per second. The initial velocity is along positive y-axis. So initial velocity is 20 j cap meter per second. So acceleration will be minus 20 I cap minus 20 j cap. If we find the magnitude of acceleration, that will be under root 20 square plus 20 square. So magnitude of acceleration will be 20 root 2. It is v minus u upon t. So divided by t. The time is 2 seconds. So magnitude of acceleration will be 10 root 2 meter per second square. So force will be equal to mass is 1 kg into acceleration 10 root 2. So force is equals to 10 root 2 Newton. From the Newton's second law, we can define another quantity called impulse. Impulse is defined as the sudden change in linear momentum when force is applied for small amount of time, that means time tends to 0, it is very small, but effect of force is very large, then we tend to say that impulse is acted. Now from the Newton's second law, the mathematical formulation is F is equals to dp by dt. So F into dt is equals to dp, because due to the impulsive force, due to the sudden force, the momentum of the object is changed. So basically impulse is defined as change in linear momentum. From this, if we integrate both the side with respect to time, we will get change in linear momentum as integration f dt. Impulse is denoted by I or J, you can use either of the term, is equals to integration f dt. The SI unit is force into time, that is Newton into second, or it is also defined as change in linear momentum, so Newton into second or kg meter per second. Impulse is the vector quantity. Now as we are using the integration here, we are ultimately finding the area under the curve, because integration means area and differentiation means slope. So the area under force time graph will give us the impulse or change in linear momentum. Let us see one example on that. In this question, a force time graph is given. The force is in Newton and time is in seconds. We want to find the impulse from t is equals to 0 to t is equals to 4 seconds. Here it is the force time graph, and as seen before, the area under force time graph will give us the impulse. So magnitude of impulse will be area of this triangle. Area of the triangle is half into base into height. Base here is 4 seconds and height is 100 Newton. So impulse will be 200 Newton second. Let us see another example on it. In this example, the position time graph for an object is given. We want to find the impulse at t is equals to 2 seconds. From this graph, we can see that for 0 to 2 seconds, the object is moving with constant velocity. As the slope of position time graph gives us velocity, the slope is constant for 0 to 2 seconds, so it is moving with constant velocity. But suddenly at t is equals to 2 seconds, the velocity is changed. Now it is moving with some other velocity for 2 to 4 seconds. As velocity is changed, linear momentum is changed, so we can see some impulses applied. We want to find impulse at t is equals to 2 seconds. That is simply equal to change in linear momentum at t is equals to 2 seconds. Let's say mass of an object is given 1 kg. So the velocity of object before 2 seconds, let's say that is initial velocity of object before t is equals to 2 seconds. The velocity is found by the slope of this graph. The slope will be 4 by 2, that is equal to 2 meter per second. Now the velocity of object after 2 seconds, let's say it is final velocity, so it is after t is equals to 2 seconds, that is equals to again 4 by 2. but in this case the velocity will be negative because the line is making an obtuse angle with the horizontal. So the slope will be negative, so velocity will be -2 meter per second. Now impulse is the change in linear momentum, that is equals to mv minus mu. So I will be equal to mass is 1, final velocity is -2 minus mass is 1 into initial velocity is 2. So this will give us the answer -4 Newton second. So in this way we can find the impulse from both force time graph or position time graph.